let us start a next part of rotational dynamics. We have already started some part about the non-uniform circular motion in the last slide, so we will continue it here. In non-uniform circular motion, the acceleration basically is represented by or given by rate of change of velocity like dv by dt. But in circular motion, vector v is given by the equation that is omega cross of r. So in circular or rotational motion, the linear velocity of a particle is given by equation omega, means angular velocity cross of vector r. It is a cross product of omega and r, which gives the resultant quantity is linear velocity. Now, as linear velocity is this and acceleration is known to us in this form, so substituting v in this equation, we get acceleration as d by dt, means derivative of this omega cross of r. As omega and r both are variable, no one is constant, so we cannot take anything outside the derivative. So here UV rule is applied. First term constant, derivative of second term is constant, derivative of first, like this. So here first term constant, derivative of second, here second term constant, derivative of first. So we got acceleration as omega cross of v plus this d omega by dt is alpha cross of r. This I already explained to you in the earlier part. So from this equation, it is observed that this acceleration vector is equal to sum of two vectors. When any vector is equal to sum of two vectors, it means that sum of the two vectors are said to be resolved part of that vector. It means this vector A is resolved into these two components, these two vectors, and the two vectors are said to be components of that vector. Hence, this vector A is equal to, what is omega cross of v? So omega cross of v is a radial component of acceleration. Now, why the direction of this is considered along the radius and toward the center? So that is again according to the concept of the direction in vector product. Omega direction is along the axis. It is perpendicular to your screen. V direction is tangential. So omega is perpendicular to your screen and v is tangential to the path. So you have to take a product, this omega to v. Omega to v means in upward direction, like omega to v. So the direction of radial acceleration, so arrange your curved fingers from this omega to v, means omega to in this upward direction, like north direction, omega to v. You arrange the curved finger and see the direction of a stretched thumb. The direction of stretched thumb will be like this. So that is along the radius toward the center. So omega cross of v, the direction is coming in this direction. So whenever the particle is located here, the velocity vector is like this. So curved finger direction from omega to v means from up towards in this direction, means from this omega vector towards this direction. So stretched thumb of the right hand is in this direction. So that is the direction of radial acceleration. Now why alpha cross of r is called as a tangential acceleration? Now direction of tangential acceleration is along the tangent, as the name is tangential acceleration, means it is along the tangent. Now alpha is also axial vector, means it lies along the axis. As long as the particle is revolving in anti-clockwise direction, alpha is upward. So alpha direction is upward. So take the cross product of alpha cross of r, means from this upward direction toward r. Toward r means in this direction. So alpha to r. Then see the direction of your stretched thumb. The direction of stretched thumb is in this direction. In this direction means it is along the tangent. So whenever we take the cross product of alpha to r, alpha cross of r, then the direction of tangential acceleration is this. It means here the net acceleration is sum of two acceleration, and the two acceleration are mutually perpendicular to each other. One is along the radius toward the center and another one is along tangent. As the angle between these two vector is 90 degree, so magnitude of this resultant of these two vector is given by formula under root of p square plus q square plus 2pq cos theta. Theta is the angle between these two vector. Angle between these two vector, that is along the radius toward the center and along tangent, is 90 degree. Radius tangent always angle is 90 degree. Hence that cos 90 become 0. As cos 90 becomes 0, the magnitude of resultant of the two vector in which the angle is 90 degree is simply given by under root of p square plus q square, that is ar square plus at square. So magnitude of net acceleration is under root of ar square plus at square. So what is the magnitude of ar? So this is said to be a magnitude of net acceleration. What is the magnitude of radial acceleration? The magnitude of radial acceleration is omega v. But how omega is written? Omega is written as v by r. As the omega is written v by r, so it becomes v into v by r, that is v square by r. So radial acceleration is v square by r. See, this radial acceleration is omega cross of v. So radial acceleration formula is omega v is also true. This is in magnitude. Why the magnitude is considered only omega v? Because while taking the magnitude, it is product of magnitude of two vector and sine the angle between them. Angle between omega and v is 90 degrees. So sine 90 is 1. So magnitude is straightway is taken as omega v. Omega is v by r, so it will be written as v square by r. Again it will be written one more form, v equal to r omega or omega r. So it will be written as omega into omega r, that is r omega square. So radial acceleration can be written in three different forms: omega v, v square by r, or r omega square. Whereas tangential acceleration in magnitude, it is simply written as alpha r, because angle between alpha and r is 90 degree. So whenever you take the magnitude, it is alpha r sine 90. Sine 90 is 1. So it is simply alpha r. Hence the net acceleration in non-uniform circular motion, or it is simply said as the circular motion, is under root of this ar term, that is v square by r whole square. So radial acceleration is v square by r whole square and tangential acceleration square. So radial acceleration can be represented by this formula. So here if you further simplified, this net acceleration is under root of v raised to 4 upon r square plus at square. Now what is the role of this radial acceleration in circular motion? The role of this radial acceleration in circular motion is to maintain circular motion. So this acceleration maintains the circular motion of a particle which is performing a circular motion. It acts as a tying agent for the particle and the center. Whereas a tangential acceleration changes the speed. As long as this tangential acceleration present in a circular motion, it changes the speed. Suppose this direction of tangential acceleration is same as that of direction of revolution of the particle, then it increases the speed. If the direction of tangential acceleration, let us consider opposite to the direction of revolution of particle. Suppose the revolution of particle is in anticlockwise direction and direction of tangential acceleration is opposite to this, then it will tries to decrease the speed of the particle. So whenever tangential acceleration is present, so it either increases the speed or decreases the speed. Here we are considering a particle which is performing a circular motion. So particle surely have some certain mass. Now in further, if we consider this mass into this acceleration, then this expression get converted into force expression, like multiplying the mass on both sides of this equation, you will get net force is equal to under root of Fr square, that is a radial force square, plus tangential component of force square. So this mass into acceleration is radial force, centripetal force, and this Mass into tangential acceleration is tangential force. So net acceleration or net force of these two will be somewhere in between them. So net force will be somewhere in between them. So considering the effect of this as well as this, here we cannot predict either effect of this should be more or this should be more. If this is 0, then particle no longer perform the circular motion. If radial acceleration is 0 or radial force is 0, then there will not be a circular motion maintained of the particle above that center, and particle no longer performs circular motion. If tangential acceleration present means tangential force present and this is absent, then particle is moving tangentially, but particle no longer performs circular motion. But in other case, if we think if tangential force 0, tangential acceleration is 0 and this is not 0, then there is no role of change in speed, but circular motion is maintained. So in that case, the particle perform uniform circular motion. So let us revise this. If this 0, tangential acceleration 0, tangential force 0, then this is present, it maintains the circular motion, and that circular motion is said to be a uniform circular motion in which there is no chance of increase in the speed, decrease in the speed means no change in the speed. But if this is 0, particle no longer performs circular motion. The circular motion of a particle cannot be maintained, and this acceleration, this force takes the particle tangentially. Now let us study the next part. So here is one more force observed in a circular motion, that is said to be a centrifugal force. In the last part we have discussed about the two forces. One is a radial force, that is also called as a centripetal force. It is along the radius toward the center. Another force is a tangential force. It is responsible for change in the speed. Here in circular motion, it's one more force which is the effect of circular motion, that is the centrifugal force. It is a pseudo force. Like in the motion of lift, you have studied, when the lift lowers, then the pseudo force is upward. When lift moves up, then pseudo force is downward. Like this, in circular motion, the effect of centripetal force is also observed, and that is along the radius away from the center, that is called as a centrifugal force. Now we will study the effect of this centrifugal force by dynamics of circular motion. Dynamics means the study of different kinds of forces in circular motion. Dynamics means considering the motion with consideration of force, with cause producing it. So in dynamics we are studying the various forces. So in dynamics of circular motion, if we take the uniform circular motion, in uniform circular motion there will not be a presence of tangential force, there will be only centripetal force. But along with the centripetal force, one more force is present, that is effect of circular motion, that is the centrifugal force. For example, whenever the mixer grinder grinds something, then all the things are pushed radially outward, that is due to effect of circular motion, that is called as the centrifugal force. If you tries to place anything on rotating body, and if the speed of that rotating body is increased, then the body which is placed on that rotating body, it will be pushed radially outward, that is due to centrifugal force. You know one more example, like merry-go-round. When merry-go-round rotate, all the toys which are suspended to the merry-go-round, they flies up, they move radially outward due to one force, that is called as a centrifugal force. So as the name itself, centrifugal force is a force which is away from the center, that is called as a centrifugal force. It is an effect of circular motion. Once circular motion begins, this force start acting on the body, like in case of a lift. If the lift is at rest, no existence of the pseudo force, but whenever the lift moves, as its velocity changes, then the effect of that pseudo force comes into the